Hey everybody, how's it going today? I am Q the Geek, and today we are talking about the product development process that I go through with my clients. We're going to be covering the client interaction, working out the technical specifications, and the brainstorming portion. We're also going to be starting a new project, which is a mailbox notification system, which I am calling the You Got Mailer. Let's get into it. So as I mentioned in the intro, the new project is going to be a mailbox notification system. This is going to be a small little device that is going to go into my mailbox and trigger when the mail has been delivered. This is going to be a fairly simple little piece of tech, and I think it's going to be a lot of fun to design and kind of show off the whole process of how product development works from beginning to end. We're going to be going through, and today we're going to talk about how I would go through with my client interaction. But in the future episodes, we're going to be covering how we're going to design the schematic, the circuit board, write some more firmware, build the whole thing up, and get it implemented. So let's get started with the client meeting. So in our meetings with our clients, we'll sit down with them and they will explain to us their idea and their project, what it is they want to do and how they want to do it. This is usually going to be a high-level meeting where they're going to explain to us just kind of what their ideas are, and we'll break it down into a lower-level concept later on. From here, we start working out what specifications we need based off of the I/O. We're going to start thinking about what things we're looking for and how we're going to implement that. We're also going to be doing a little bit of minor brainstorming with our clients to really nail down what it is they want. From here, we're going to move on to the contract. Now, the contract says what it is that we are going to do and what it is that the client will accept as our finished work. This is something that helps protect us as well as our clients. This also helps to prevent scope creep, so that the client can't come and say, hey, I want some additional features when we're close to our deadline for delivery. What they'll have to do is do a work order change that would basically say, we are now going to add these additional features, but this changes when our delivery date is. This helps protect us as well as them, because we no longer have to worry about delivering features that weren't originally spec'd in an unreasonable timeline. They can hold us to the point where they can say, this is what you said you would deliver, and this is what we delivered. We'll also nail down how many prototype units we will deliver to them. So generally speaking, we will usually deliver about 5 prototypes, 5 to 10, based off of the design. And that way the client has some product in hand that they can take off and show, and hopefully get some more money from venture capitalists and some different things like that if it's a small startup. Or they'll have enough that they can take back into a production environment that will get them started before they ramp up on their full production. We will also determine what deliverables they will be receiving. This will be things such as the production files, the prototypes, and if they'll be receiving the source files. That can be the source code as well as the source files for the fabrication of any circuit boards. Generally speaking, we will maintain our source files so that if a change needs to be made, our clients can come back to us and we can be familiar with the product already and be able to make the change. But depending on circumstances, we might be releasing the source files to the clients on delivery. Now in a separate meeting, we will start going through and brainstorming. Based off of the requirements, we're going to start figuring out what kind of I/O are going to be required for this project. We're going to work from a high level down to low level and break everything down into steps and blocks. We're going to talk about what controller would be best for the job, whether it's a microcontroller or a microprocessor. If you don't know the difference, be sure to check out the card here. We're also going to be working out how to power it, such as, are we going to be running this off battery, or is it going to be using mains power? Do we need to include a regulator? If it's off of mains power, can it just be a simple low dropout regulator? Or if it's off battery, do we need to use something such as a switch mode power supply for better efficiency? We're also going to look at what peripherals we'll need for this device, such as additional radios, other switches, things such as EEPROMs for additional memory, and that kind of stuff. We're going to work out if there's any additional communication protocols that need to be used. If we're going to be doing anything with RF, then we might have to work with some pre-existing protocol. If we're dealing with things such as memory modules, we may have to use SPI or I2C. And we also have to consider how we're going to be programming this device in the long run. Some devices can be programmed from the manufacturer. Others will require a programming jig with a programming header on the board. So now let's think about this for our project. Let's pretend for a second that the client has come in and requested that we design them a mailbox notification system. They want it to be able to send an email to notify the homeowner when the mail has been delivered. So we know we're going to need a few things such as a wireless communication protocol. We're going to have to use something like Wi-Fi to get this thing connected up. We're also going to need some sort of switch to be able to determine the state of the mailbox. We're also going to have to think about how this is going to be structured and how we can get this to communicate and relay correctly. So let's jump over and take a look at the block diagram for what this will look like. Okay, so let's go ahead and start and take a look at this. We're going to need to start off with our microcontroller. For this, we're going to use the ESP8266. The reason for this is it's small, it's cheap, and it has Wi-Fi built in. The next thing we're going to need is some way to read the mailbox state. So this can just be a simple switch. This is going to be something we're going to use a magnetic read switch for, and that way it actually works off of electromagnetics to give us a signal. So the next thing we need to think about is power. We're going to be running this off of a switch mode power supply, and from the switch mode power supply we are going to power that off of a battery pack. This will be something like a AA or a AAA pack. And that's pretty much it for our block diagram. Really doesn't take much for this project. It's just a simple I/O switch, microcontroller, power supply, and a power source. Now we will have to do a lot more back end on the programming side, but we'll get to that later. Now next we need to think about the circuit for a second and how we're going to go through and design this. So we're going to start with our microcontroller, which has built-in Wi-Fi. We're going to go through and put a few filtering caps right off of that to provide some filtering and buffering for the power source. We're going to need to provide a ground source, and we'll need our read switch. We'll put a little M off to that to make sure we note that it's magnetic. Now we'll need our switch mode power supply. Now generally speaking, we'll have to dig into this a little bit later, but what this is going to consist of will be another capacitor, an integrated circuit, there'll be an inductor, and there'll be an input capacitor. There may also be a resistor divider, but we won't worry about that right now until we actually spec out a part. Now this will be connected directly to our battery pack, which for right now we'll just assume will be a AA pack. One more thing we'll probably need will be a pull-up resistor off of our magnetic switch. We might change that to be a pull-down resistor, but we'll look at that later. And for right now, that should be pretty much it. It's not that complicated of a circuit, and it shouldn't be too difficult to design. We will have to see if there's any additional things for the microcontroller that they recommend and spec that way. As well, we'll probably also need a programming port of some kind, so let's just go ahead and throw that on there. I think this will be a great start to get us going, and we'll be able to take a look at this further in the next episodes to really start hammering this out. Now that should be enough to get us started on the idea and to get us thinking about this. We're going to start brainstorming over this a little bit more as we move into it further, but this will give us an overview. Now as always, I want to throw a big shout out to my Patreon supporters. That'd be Tom Van Loon and Yannick Poirier. Thank you so much for your support. If you want to support the channel, take a look at my Patreon link, which is patreon.com/QTheGeek. Also, for the first time, I want to be throwing a big thank you over to my sponsor, PCBWay. They're going to be sponsoring this project and providing the circuit boards. Other ways you can support the channel is by liking this video, commenting, subscribing, and sharing this content with your friends, family, and coworkers who you think might be interested in this. If you haven't already, be sure to subscribe so that you can follow on with the progress of this project and be able to build your own. Thank you so much for watching, and we'll see you in the next one.